Alright, so welcome to the first official unit of grade 10 math. This will be the first lesson on section 1.1, Connecting English with Math. In this lesson, what we're going to learn to do is we're going to learn to be able to find the point of intersection of two lines. So two lines, we're going to be able to find out the point of intersection by graphing those two lines. Okay. First off, let's learn what a linear system is. A linear system is two or more linear equations that are considered at the same time. So if I have two linear equations, let's say 3x plus 1, so y equals 3x plus 1, that's one linear equation. Here's another one, y equals x minus 5. Okay, so I have two individual linear equations here. If I consider them at the same time, I get a linear system. Okay, two lines, we consider them at the same time, we can find out where those two lines intersect. Okay, so later in this unit, we're going to learn some algebraic ways for finding that point of intersection, but right now we're just going to learn the graphical way of finding the point of intersection. Let's also just quickly refresh. The equation of a line is y equals mx plus b. Hopefully you remember that from grade 9. X and y stand for all the coordinates on the line. Okay, every coordinate is an xy coordinate. Okay. X being the horizontal axis, y being the vertical axis. Okay. M stands for the slope. The slope we know is rise over run. So the change in y over the change of x. Okay, that's where our slope is, and our y-intercept is b. Okay, so where the line crosses the y-axis, this is our y-axis right here. These would be the y-intercepts of those two lines. Okay, so M is slope, b is y-intercept. Okay. Enough of that, let's go on and do an example. So finding a point of intersection. The equations for two lines are x minus y equals -1 and 2x minus y equals 2. Those are my two linear equations. What are the coordinates of the point of intersection? So we want to find the point of intersection of this linear system because we're going to consider these two lines at the same time. Okay. Possible ways to solve this problem. We can graph using slope and y-intercept. So if we put the equations into this form, y equals mx plus b, we know how to graph those from grade 9, okay, and we can find out where they intersect, find the coordinate of where they intersect, so whatever this coordinate is, whatever the xy coordinate of that is, that'll be our point of intersection, okay. We could also graph using intercepts, okay, we could find the x-intercept and y-intercept of each of these lines. If I know the x and y-intercept of this line, I can plot them, connect them, and I've got the line, okay. Do that for both of them, find where they intersect, okay. We'll do one example like that as well. Or you could use a computer algebra system or Geometry Sketchpad, so a graphing calculator or any math software that graphs has the ability to graph lines or other functions you could use. Okay. So let's start off for this first example. Let's solve it by graphing them using our slope and y-intercept. So in order to do that, we have to first rearrange the equations into y equals mx plus b, because as you'll see here, they're not in that form yet. Okay, so what I have to do, I have to get y by itself on the left side of the equation and move the x and the constant to the right side. So the y is already on the left side, so I'm just going to leave it there. And I'm going to move that x to the other side. It's going to become negative. It's positive on the left. That means it's going to be negative on the right. And that -1 can just stay there. Okay, I'm almost in the form y equals mx plus b now. The only problem is my y is negative. Okay, in order to make that y positive, I just have to multiply this entire equation by -1. So I can't only multiply the y by -1, I have to multiply every term by -1 to keep it equivalent, okay? So multiply everything here by -1, times -1, times -1, times -1, okay? Multiply everything by -1 to keep it equivalent, and what that'll do, that'll just change the sign of every term. So I'll get y equals x plus 1. Okay, so there's my first equation in y equals mx plus b form. Okay, next equation, so it's going to be a similar process. Okay, the y is already on the left, so I'll leave it there. It's a negative y again. I'm going to move the 2x to the other side. It's going to become negative. It's positive on the left, so it's going to be negative on the right. And I'm going to leave that positive 2 on the right, because that's where I want it. Okay, once again, same problem, that y is negative. What I'm going to do is I'm going to multiply every term in here by -1 to change the sign of that negative y. Okay, because negative y times -1 gives us a positive result of positive y. Okay, so multiply every term by -1, it's just going to change the sign of everything. That keeps it equivalent. Okay, so that becomes positive, this becomes positive, and this now becomes negative. Okay, All right, another way to think about it, you could have thought of it as you can move this y to the right and move these two to the left to get y by itself, and you would end up with x plus 1 equals y, and that means that y is also equal to x plus 1. Okay, you can think of it that way as well. Or you can just multiply it all by -1. That's the way I like to think of it in my mind. Okay? So we have our two equations. Whoops. Now we can graph them using our slopes and y-intercepts. Don't forget, if you don't see a number in front of the x, there is an invisible 1 there. Okay? That x is being multiplied by 1. Okay? So the coefficient of the x is a 1 if you don't see anything there. Okay? So let's graph these. So this first one here, 2x minus 2, our slope is 2. Okay, there's a 2 in front of the x. And we know that every whole number is over 1. So our slope is 2 over 1. So that's our rise over our run. So our rise is 2, our run is 1. So our rise, and this is our run. Why is this writing so bad? There we go. So 2 over 1, rise over run. Okay, and our y-intercept, so our b value is -2. For this one. So that's our y-intercept for this line. So let's plot our y-intercept. So at -2 on the y-axis. And our slope is 2 over 1. And we know that's rise over run, so we have to rise 2 and run 1. When the numbers are positive, positive means we go up and to the right. Okay? If the rise was negative, that would mean we go down. If the run was negative, that would mean we go left. Okay? But because our numbers are positive, that means we go up and right. Okay? Positive is up and right, negative is down and left. Okay? So I'm going to go continue this line, go up to right 1, up to right 1. Okay? And now I'm going to continue this line. So to continue it to the left, I just do the opposite of what I was doing to go to the right. Okay? So to go to the left, I now go down 2 and left 1 instead of going up 2 and right 1. So just continue it, go doing the opposite method. Okay? Because a slope of -2 over -1, that would mean down 2 and left 1, is equivalent to the slope of 2 over 1. -2 divided by -1 is equal to 2. And so is 2 over 1. 2 over 1 is also equal to 2. So that's the same slope, okay? Those two. Okay, awesome. The only way you're going to get a line going the opposite way is if you have either your rise or your run as negative. Only one of them, if only one of those is negative, your rise or your run, that'll get your line going the other way. If you had -2 over +1, that would mean you go down 2 and then right 1. Okay, and then that would get your line going this way. Okay, so we've got that line graphed. Let's graph y equals x plus 1. My slope is 1 because I know there's an invisible 1 in front of that x, and my y-intercept is at 1. Okay, and I know any whole number is over 1. So my slope is actually 1 over 1. So I'm going to plot my y-intercept first. That's always your first step. Next, you're going to plot your next points to the right by using your rise over run, your slope. Okay, so I'm going to go up 1 over 1. That's my next point. Up 1 over 1. There's the next point. Up 1 over 1. There's the next, and keep going. Here we go. And now to continue the line to the left, I'm going to do the opposite of what I did to the right. So I'm going to go down 1 and left 1. Instead of up and right, I'm going to go down and left to continue this line. Okay? Now I'm going to connect these dots with a nice straight line. So there's my one line. Here's my other one. I'm going to label which line is which, just so I can remember. So this is my y equals 2x minus 2. And this is y equals x plus 1. And now I'm going to look, where do these two lines intersect? They intersect right here. That's my point of intersection. It's my point of intersection. Count the coordinate, okay? So this coordinate right here has an x coordinate of 1, 2, 3. And a y coordinate of 1, 2, 3, 4. Okay? So my point of intersection is at 3, 4. That's where those two lines will intersect. Okay? Now the next step, check and make sure you did this right. Check and make sure you graphed it properly and you found the right point of intersection. If you did, this point should be on both of these lines because those lines intersect at that exact point. So remember, every point has an x and a y coordinate. So if I plug in 3 for x and 4 for y into both these equations, it should keep the equations equivalent, okay? They should stay balanced, so the left side should equal the right side for this equation, and same for this one. If I plug in 3 for x, 4 for y, the left side should be equal to the right side, okay? That'll tell us that that point is in fact on both lines. So the nice thing about these questions, you can always check your work, okay? So you're going to plug in 3 for x, minus, I'm going to plug in 4 for y. And I know that should be equal to -1 if this point is on that line, and 3 minus 4 is in fact -1. Good. So 0.34 is on that line. Now let's check and make sure it's on this one. Plug in 3 for x, minus, plug in a 4 for y, equals 2. Now let's check and see if 2 times 3 minus 4 is equal to 2. Remember your order of operations, you do multiplication first. 2 times 3 is 6, minus 4. 6 minus 4 is 2. So 2 equals 2. Therefore, that point is on that line as well. Therefore, that is the correct point of intersection. So you just write a nice conclusion now. Coordinates of the point of intersection are 3, 4. And you're done your question, okay? Just a quick review of the steps we went through. We chose a graphing method. We used slope and y-intercept. We then graphed them and located the point of intersection. We checked to make sure that the point of intersection is on each line. And then we wrote a conclusion. Okay. Let's do another example. Let's find the point of intersection of these two lines. Okay. Once again, the ways you can do that, we can graph using slope and y-intercepts. We could rearrange these into slope and y-intercept form and graph them. Okay. In order to do that, it'd be a little bit more work with this because there's coefficients in front of the y, so we'd have to do some dividing to get y by itself. But that's okay. We could do that. Or we could graph using intercepts, which you're probably not as familiar with. I think in grade 9 you probably did a lot of graphing using slope and y-intercept. So let's practice one where we graph using intercepts. Okay. So just a quick review. If I've got a line that looks like this, you'll notice it goes through the y-axis and the x-axis. Okay. All lines will do that unless they're horizontal or vertical lines. Okay. So almost all lines will go through the x and y-axis. Okay, so we can graph lines if we find the x-intercept and the y-intercept and then connect them and extend the line. We'll be able to graph it based on those x and y-intercepts. So there's actually an easy way to find x and y-intercepts. So for our first equation, well, first off, we'll find the x-intercept. I'll show you how we're going to do that. Okay, if you look at, so my first equation is 3x minus 2y equals 12. Okay. If we want to find the x-intercept, so where it crosses the x-axis, so this point right here, we know the y-coordinate of every point, no matter where the point is, every point on the x-axis has a y-coordinate of 0. Okay. It's not up or down at all, it's right on the x-axis. So we know every x-intercept has a y-coordinate of 0. So I can substitute in 0 for y and solve for what the x-intercept actually is. Okay, so 2 times 0 is 0, so I have 3x minus 0, which is just 3x, equals 12. Divide the 3 away from the x, that's 3 times x, so I divide the 3 to the other side. 12 divided by 3 is 4. So my x-intercept is at 4, 0. It crosses the x-axis at 4. Okay, now let's find the y-intercept. You can probably guess based on what we did for the x-intercept what we're going to do with the y-intercept. Okay. For the y-intercept, you'll notice the x-coordinate of every point on the y-axis is 0. It doesn't move left or right at all. Every point has an x-coordinate of 0 on the y-axis. So every y-intercept has an x-coordinate of 0. So I can substitute 0 in for x and determine what the y-intercept is. Okay, 3 times 0 is 0. 0 minus 2y is negative 2y. That's a negative sign there, negative 2y. Then to get y by itself, I'm going to divide the negative 2 to the other side. 12 divided by negative 2 is negative 6. So my y-intercept is at 0, negative 6. Okay, so that's where it crosses the y-axis. Okay, so I could now graph my first line here. Let's go ahead and do that. So I know it crosses the x-axis at 4. 1, 2, 3, 4. So at 4, 0, there's my x-intercept. And I also know it crosses the y-axis at negative 6. So at 0, negative 6, 1, 2, 4, 5, 6. There's my y-intercept. Okay? So I can connect those 2 points with a nice straight line, and then that will tell me what that line will look like. So I'm just going to extend it, try and get it going through the exact middle. That way my point of intersection will be as accurate as possible. Let's get it extended a bit more. Alright, that looks like it's pretty accurate. Let's go with that. Okay, so I extended the line through the point, through the intercepts. That's what the line of 3x minus 2y equals 12 looks like. So even though we didn't put it into y equals mx plus b form, we were able to get a pretty accurate representation of what that line looks like. Okay, now let's do the other line. Okay, so our second line was 2y minus x equals negative 8. Okay, to find the x-intercept, so we'll do the x-intercept first. To find the x-intercept, remember every point on the x-axis has a y-coordinate of 0, so I'm going to set y to equal 0 to find the x-intercept. So 2 times 0 is 0. 0 minus x is negative x. So negative x equals negative 8. To get x positive, multiply the whole equation by negative 1. That'll change the sign of every term in the equation, so x equals 8. Okay, so my x-intercept is at 8, 0 for that line. Now let's find the y-intercept. To find the y-intercept, you just set x equal to 0. Okay, so 2y minus 0 equals negative 8. 2y minus 0 is just 2y. 2 times y equals negative 8. So to get y by itself, divide the 2 to the other side, because division is the opposite of multiplication. Negative 8 divided by 2 is negative 4. So my y-intercept crosses the y-axis at 0, negative 4. Let's plot those 2 points, connect them, and then find what that line will look like. Okay? So 8, 0 will be the x-intercept. 1, 2, 3, 4, 5, 6, 7, 8. 8, 0. And the y-intercept was at negative 4, is that right? Yeah, and my y-intercept is at negative 4. 1, 2, 3, 4. Good. So now let's find out what this line looks like. Try and get as accurate as I can. And I'll just extend it a little bit. There we go. That should be that line. Let me just label the lines so I know. So this was line 1. This was line 2. And it looks like my point of intersection is right here. Okay, so my point of intersection is at 1, 2. So just 1, 2 on the x-axis. So point of intersection is at 2. And then negative 1, 2, 3. Negative 3 on the y-axis. Okay, so there's my point of intersection for those 2 lines. So I was able to do that using the intercepts and just extending the lines. Because remember, these lines continue on forever. Okay, they don't stop. Okay. Okay, so next step, check and make sure 2, negative 3 lies on both lines to make sure we found the appropriate point of intersection. Because with graphing lines, there is the opportunity to make error with graphing. You might not find the exact point of intersection, especially when we start getting into decimal answers. That's when the algebraic method will come in handy more often, okay? But right now, when you see an exact point of intersection like this, looks like it crosses exactly at 2, negative 3, there's a good chance that is the exact answer, okay? But just double check to make sure. So make sure 2, negative 3 lies on both of the lines. Remember, every coordinate is an x, y coordinate. Okay, so let's get the equations of our lines again. First one is 3x minus 2y equals 12. 3x minus 2y equals 12. So just plug in 2 for x, negative 3 for y. Minus 2 times negative 3 equals 12. So make sure 3 times 2, so 6, minus 2 times negative 3. So I have a negative times a negative. That'll give me a positive 6. So good, this works out. 6 plus 6 is 12. Good. So 2, negative 3 is on this line for sure. Now let's make sure it's on the other line. That'll verify that that is the point of intersection of the 2 lines. The other line is 2y minus x equals negative 8. 2y minus x equals negative 8. So we'll plug in negative 3 for y. So just replace the y with a negative 3, put it in brackets, okay, so you remember to do the multiplication, and you don't accidentally just subtract those two, okay. Minus x is 2. See if that's equal to negative 8. 2 times negative 3 is negative 6, minus 2. Negative 6 minus 2 is negative 8. Negative 8 equals negative 8, therefore it's on that line. Therefore, those two lines must intersect at that point, since that point is on both of those lines. Awesome. Write our conclusion. Point of intersection is 2, negative 3. Make sure you always write it as an x, y coordinate. Okay. Good. Now let's try a word problem. This is why this lesson is called Connecting English with Math, because we're going to have to be able to read sentences, look at some phrases, and change the phrases into algebraic equations, okay, that we'll be able to graph. Okay, so Brian and Catherine want to get internet access for their home. There are two companies in the area. Internet Plus charges a flat rate of $25 for unlimited use. Techies Inc. charges $10 plus $1 per hour for use. Okay, so after how many hours will the cost of Techies Inc. be the same as the cost of Internet Plus? So look at that question. After how many hours? First figure out what the question is asking you to find. Okay, so after how many hours will the cost of Techies Inc. be the same as the cost of Internet Plus? That's asking. So when you see that word "same," so that's saying when are the two companies the same? We want to find out what is the point of intersection of those two companies. Okay, we want to figure out where those are the exact same. So if we make equations for both companies and then graph them, we want to figure out where they're the exact same. So we're just looking for the point of intersection. Okay, this question is asking us for that in a fancy way. It's asking for the point of intersection. So let's go ahead and just find that quickly. Okay, so before we can do that, we have to first notice there are two companies. We're working with linear systems where we're considering more than one linear equation at the same time. So when you see there are two companies, it's probably a good idea to make one equation for each company. That'll give us two equations. So if we can make an equation for the first company, okay. Oh, before we do that, let's look at what our variables are, okay. So our variables are hours and cost, okay. So Internet Plus charges a flat rate of $25 for unlimited use. So hours doesn't really apply to that company because they just charge a flat rate. Okay? So we know that the cost of Internet Plus, so I'll use C equals cost. C equals cost. The cost of the first company is just $25. Okay, it costs $25 for unlimited use. The second company, however, the cost of the second company is equal to, they charge $1 per hour. They charge $1 for every hour. So I'll make H equal to hours. Okay, they charge $1 times how many ever hours the company uses, how many ever hours the person uses. Okay, they charge $1 per hour plus a $10 flat rate. So 1 hour, $1 times every hour plus $10 flat rate. Okay, for use. So the second company the cost depends on how many hours the person uses the internet for. First company doesn't depend on hours at all. It's just 25 bucks. Okay, so we want to figure out after how many hours will the cost be the same. So how many hours will it take to get this company to cost $25? Pretty much. Okay, that's what this question is asking us. Let's graph the two lines to be able to figure that out. Okay, so you'll notice this company is already kind of in the form y equals mx plus b. Even though the variables aren't the same as y and x, our variables in this case, cost is our dependent variable and hours is the independent variable. The cost depends on how many hours. Okay, so even though it's not y and x, it is in the form y equals mx plus b. So this is our slope, okay, and this is our y-intercept. So we can graph it. So 1 is our slope, 10 is our y-intercept. We can graph it based on that. Okay. So let's go ahead and do that. Let's graph the first one first. So the cost is, let's make our scale actually first. So I'm going to want, this will be my cost. My cost, I'm going to make this go up by 5s. 5, 10, 15, 20, 25. I know my cost of the first company is 25 all the time. It's never going to go up or down. The cost is always 25. So my cost is just a horizontal line through 25. Okay, that's what the line looks like for the first company. Okay, just a horizontal line through 25. I'll make it red so we can see it. Good. Okay, so there's the graphical representation of C equals 25. It's just a horizontal line through 25 because the cost is always 25. Okay. Our independent variable is hours. Okay. We're going to need this for our second company here. Hours. Also make that go by 1, 2. Actually, I need to make that go by. I'll make that go by 2, 4, 6, 8, 10, 12. I'll make that go by 2s, so I can make sure we can get our point of intersection on here. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. Also, one more thing to note before we graph the second one. Anytime you have an equation, let's say you have an equation y equals 5. That would mean the y value is always equal to 5, so it would just be a horizontal line through 5 on the y-axis. But let's say you have the equation x equals 4. That means x is always 4. The value of x is always 4. It never goes left or right, so that would just be a vertical line through 4 on the x-axis. Okay? That's just one thing to keep in mind. Knowing how to graph vertical and horizontal lines is important. Okay? So let's graph the second line. It has a y-intercept of 10, so it crosses the y-axis of 10. And it has a slope of 1. So slope is 1 over 1. So that means it's going to go up 5, and it's also going to go over 5 at the same time. Okay? 1 over 1 is equal to 5 over 5, which is equal to 13 over 13, or any number over itself. Okay, so I'm going to use this slope, go up 5, over 5, up another 5, over 5 more, 10, and up 5, and over 5 more, 15, up 5, over 5 more, to 20. Okay, I'm going to connect that with a line. There we go. And you'll be able to see now where these two lines intersect. They intersect right here. And this is at 25. Or sorry, on the x-axis it's at 15. Between 14 and 16 it's at 15. And the y-coordinate is 25 for that point of intersection. So my point of intersection is at 15, 25. Okay? Now I have to be able to interpret this point of intersection. I have to know these two companies are the same. So I'm going to write this like this here, make it a little bit faster. So what did the question ask us? The question asked us, after how many hours will the cost of the two companies be the same? So after how many hours? So hours is my x-coordinate. So I'll look at the x-coordinate of my point of intersection. It's 15. So the cost of the two companies will be the same after 15 hours. The cost of the two companies will be the same after 15 hours. The cost will be $25. Okay? By looking at the y-coordinate, 25, I know the y-coordinate is the cost. So the cost would be $25 after 15 hours for both companies. I could check and make sure that's true by plugging in 15 for H and 25 for C into both my equations, making sure that the equations stay equivalent. Okay? Let's just make this a bit bigger. Awesome, you can see that. Okay, what question B? We didn't look at that yet. Question B, if they're planning on using the internet for 18 hours, which company would you recommend? we can just look at our graph for that. You could plug in 18 for h into the second equation and see how much the cost will be. And if it's more than 25, it would be better to use the first company. If it's less than 25, it would be better to use this one. Okay, well, let's just look at our graph. So after 18 hours, so if we look at 18 hours, what will the cost be? The cost of that first company is lower than the cost of this second company. Okay, so this one is clearly better at 18 hours. So I'm just going to kind of highlight that point there. Right here. So at 18, the cost is lower for the first company than it is for the second company. So our first company, what was it called? Our first company, Internet Plus. Okay, so after 18 hours, if you're using the internet for 18 hours, if you are using the internet for 18 hours, I would recommend using Internet Plus. It will be cheaper. Okay? So there's our answer for the second one, part B, and I think we're all done, and that's it. So the important thing you want to take away from this lesson, being able to read sentences, make equations based on them. You also want to be able to remember how to graph using your slope. So slope, the m value, and your y-intercept. You want to be able to graph using that. Hopefully you also learned how to graph using intercepts, finding the x and y-intercepts of both lines and connecting them. Okay, so that's all you should take away from this lesson. Any questions, go to jensenmath.ca and have a great day.